Okay, everybody, here is the review, and I'm hoping you're going to do this. I'm not going to go through all of this because this is your homework assignment, but let's take a look at it. So today's date 10/20/20. Okay, so line of symmetry. I have a little mini equation, x equals negative b over 2a, right? Which is going to be a negative 2 over 2 times 1, which is a 2 over 2, or x equals 1 is my line of symmetry, okay? To get the vertex, plug that in, and you get 1 something. You need to do this. That'll give you the vertex. X and y intercepts. The y-intercept for sure is at 0, negative 3. Y-intercept for sure is at 0, negative 3. And you can actually get your x-intercepts by factoring, setting equals 0, or we can even use our good old-fashioned Desmos to get a lot of these. Okay, so if I go to Desmos is wonderful, right? You can just graph these. Okay, you get everything from Desmos. You can get a x squared subtract 2x and then subtract 3, and there's your parabola. X-intercepts, boom, boom. Vertex, boom, you got it, okay? Piece of cake for you, okay? Same thing on 2. The vertex, since it's in vertex form, is obviously at negative 4, negative 9. That's my vertex. Line of symmetry has to go through the vertex. My line of symmetry is at x equals negative 4. Y-intersects, again, you could even put it in your calculator or as Desmos, and you get everything here on Desmos. It's up to you, and I'm going to let you do that because I trust you can. 3, it's a translation. So anything on the inside is always going to be, let's see, where's my red pen? I want to make sure I use a different color. Opposite, okay? So anything on the inside has got to be the opposite. So I'm going to take my x plus 1 squared, shifting down 3. Okay, there's my down 3. Now, if that's my parabola, and I don't need to really make a big graph out of it, but I do know the vertex is at negative 1, negative 3. It's down here. And if I'm going to talk about domain and range, it's not that bad. So the domain, it's forever wide. It's always going both directions. As it goes up, it's always moving over. Same thing on this side. So the domain is just going to be x equals all real numbers. But the range starts at a height of negative 3 and goes up. Okay. Okay, 4. Obviously, it's got a negative here. So when I do graph this one on 4, it's going to be upside down or a frowny face. Okay. So it's going to look something like this. So therefore, that's a maximum point. To find the vertex, you can use your negative b over 2a or just use Desmos. Negative b over 2a will work. That's my negative 20 over 2 times a negative 4. That'd be a 5, I think. No, it wouldn't. Let's see, 10, 2.5, I think. So 5, Desmos won't work. You know you've got a vertex at 3, 5, so I would set it up like this. I'd go x minus 3 squared plus 5, vertex form. There's my h. And my k, you need to find the value of a, so you're going to plug in your 6 and your 0 into the equation. So I'll put 0 in for y, and I will put in my 6 for x, and I will solve for the value of a, and I'll put that value I get right here. Okay, number 6. I would just probably use Desmos on this one. I know you're going to start at a height of 10. You start at a height of 10. And the ball is going to go up and land. When it hits, this is time. This is time. This is in terms of seconds. Highest height, you could use negative b over 2a. That works. You could also use Desmos to get this. When does the ball hit the ground? That's that point right there. Okay, and that's in terms of time. So this is your assignment. This is what you need to do. I'm not going to do the whole thing for you, but that at least helps set you up. Okay, there we go. That's all I got. Please do this, submit this. You need to do this and submit this to Canvas, not Kansas, submit this. Yep, okay, there you go.